Hello, guys. Good evening, all of you. I would like to welcome you all for another successful 99x webinar session. Welcome you all. And first of all, I would like to tell something about the session, right? So this session is, as all of you know, this session will be organized by 99x, and also behind that Asia Focus Group is organizing this, and also we are collaborating with the Push Research Group in 99x. Right. Today's session is episode 1 of this session series, the idea to fruition. Right. So the next session will be episode 2, and it is about business intelligence through log analysis. It will be held on 22nd of June. Right. Let me give you some brief introduction about what is Push. Right. So Push is a market leader in Norway vehicle inspection sector. In from 99x, we create fully functional APIs for that product. Right. Today, your speaker will be Netmal Varsamana, and he's a senior product developer and expert in Asia services. And right, so that's about the brief. And yeah, so if you have within the session, if you have any questions, so you can drop those questions in the YouTube chat. Right. I hope you clear me. Right. And then yeah, no more talks. So we can go to the session. Right. So I invite Netmal to continue the session. Netmal, shall we?
Yeah, thanks, Sahil. Thanks so much. So we'll get started. So yeah, before starting, so but basically the objective of this session is to give an idea of how we develop an idea into a fully fledged product, which currently is in production and actually giving us good results and better than we expected actually. So we'll go through each stage that we performed in the project, and along the way I'll be explaining how we took some decisions and how we used Asia in those steps as well. And also we'll be having the Q&A later, so you can ask any questions there. Yeah, so let's get started. So I'll start off with an introduction about the company. So don't get the pronunciation wrong. So this is actually called Bus, not Bus. So this is the company is actually an IT supplier with that specialty in development of IT systems and also sales in the automotive industry. So they have many connections between the Norwegian workshops, like the automotive workshops there. So their main product is Buspec, which is doing inspections in the workshops. So that accounts for over 70% of the market share. So that's huge in Norway. And also they do, on average, they do 8,000 inspections per day of vehicles. So that's it about Bus. And we'll straight away dive into how what we did in the initial stages of the project. So actually the business advantage Boost has is like they already have like the records of those vehicles that are being inspected in the workshops. So they have been smart and they have kept the records, and they have almost like over 2 decades worth of data. So we had the opportunity to utilize those to our advantage. And so the main tables that we got, like just to give an idea, I won't touch upon all the tables and all that, but the main table was more than 11 GB in size. So we actually had to get that to our side and do some analysis there, because connecting directly to the DB wasn't an option, because we have to frequently do some heavy analysis, so that keeping a DB record won't be ideal. So that table actually contains some like a huge amount of inconsistencies. So I'll explain them along the way. And also we had some fields in there which are falling under GDPR, which is General Data Protection Regulation, which is being carried out in the European region. So you can look it up on Google and see what's what. So there's documentation there. And also what we did first was like we had to comply under GDPR, because we can't get private data of users of booths, like the customers, directly to our site. So what we wanted to do was like mask those fields. So as the first step, we masked the registration number and the WIN fields. So we had to extract the data and then mask them, and also create a mapping and keep it within the Norwegian team's end, and then get the mask data to our site. So what would happen is something like this. So the table would contain some fields like this. For an example, the registration number is taken here. So we would mask that registration number with like a string, randomly generated string, and create a mapping between the original and the masked. And this was kept in the Norwegian team's end, and we got this table. So if this registration number is repeated anywhere down the line, we would replace it with this only, so that preserve the integrity of the data actually. And during the analysis stages, so what we did was like in order to process that data, we like you might already know, like when you do DB joins and all that, you'll get like a pretty like huge amount of rows, like because those are products of the tables. So that the local machines of us couldn't handle that amount of data. Like it would the memory required for that was very high. So what we used was like there's this like cluster computing, like the big data used for big data projects called Databricks. So there's an implementation of that in Asia, and also you can find that in AWS as well, I think. So we use that, and we have Python notebooks and also Spark compatibility there. So Spark will be Spark was very useful in doing some heavy operations. Like it's like basically like Hadoop as well. You can search that as well. And we kept our dataset in Azure Data Lake storage. This is equivalent to like an Azure blob, but a bit different. You can compare those. I think there was some documentation there as well. I mean, in terms of the cost and all that, this is cheaper if you are doing big data analysis and all that. So moving on, like this is I took a small example, like to walk you through the process of preparing those data to the format that we need in order to develop that learning model. Actually, we use a statistical model here, and you'll see how it goes. So initially, we'll after all those joins and all that through Databricks, we would have a data set like this. So we would have this make model year fields and the mileage of the vehicle, and also a checkpoint. Like that checkpoint would indicate a defect of that vehicle. So our goal was to actually build a defect prediction system. So that was our objective. So we have these defects as checkpoints. They are called as checkpoints. So this checkpoint would be something like brake failure or something. This could be like windshield crack or something like that. So the issue was like if we pursued the make model year approach and use these fields as our uh, fields for the model, we as I mentioned, we had many inconsistencies. So sometimes these would be missing, and also these things would be switched like due to human error and all that. So in order to rectify those things, we would have had to do some heavy manual work. So that was not possible within the time frame that we have, and it's also very costly for them. So what we did was like, and they already had this in place, and they have an ID, like a third-party ID managed by a third-party company. So what they do is like they'll incorporate an ID for each vehicle category. For an example, you can see these Audi A3 and A4 models of the same year have the same ID attached to it. So what that means is like they what they do is like they categorize those cars with similar platforms, basically. Like since Audi is making A3 and A4, they would have the same platform but different body work and all that, but the engine and all would be much similar, so they would have much similar parts in them, so those are grouped together. So and also you can see like these have been assigned some other IDs as well, so that's a many to many relationship actually. So that ID actually helped us in classifying those similar cars together implicitly, because we don't have to do that ourselves using these make model year. And with this, that was rectified. So it was a huge help as well. And this ID actually didn't fall under GDPR, so it was very easy to handle it as well. And yeah, next we would transform this data into a form like this. I've taken this ID 100, so we would have many records like this, actually like millions of records. So out of those, I have taken a few like for this example. You can see that these checkpoints have been assigned as columns, and the mileage is there. So our idea is like to for this ID, we would have these mileages, and we would have all the defects as ones and zeros. Like if there's a defect, there would be a one. If there's nothing, there would be a zero at these checkpoints. So we would transform that data into a form like this. And then what we do is like based on the input that we want. So this is actually the functionality of the API. So based on the input, we should predict the defects. So in order to predict those defects based on the input, let's say we have 70,000 kilometers as the input, then like we define a window size, like a window of 10,000 here. So if you add 10,000 to the input mileage, then you get 80,000, and then if you reduce that amount, then you get 60,000. So we would consider or consider the records between these two mileages. So these are the boundaries that we have. So out of that example, we would pick these mileages. So the idea is like we should not consider all the data. For an example, if we compare this 145,689 mileage, that is too far away from 70,000. So we should not incorporate that into our prediction, because that data isn't like closer to this. So we would define like a window, something like this. For this, I have used 10,000. So we tried out different combinations. I'll show you that, and then pick those rows. And I'll take this comment, this checkpoint as the reference for now. And then what we do is like out of these selected mileages, we need to assign an importance for these mileages. So the more closer the mileage to the input, then we can assign like a good importance to that data point. So something like that. So the like the giving an importance can be done in like several ways actually. Like we can give an equal importance to all the mileages. Like we have defined some functions called step. We would have this function giving like a y equals 1 function which gives an equal importance to all mileages. And we can use something like this ramp. You can see the equation and you will get something like this. So the further you go, the lesser the importance, basically, and something like this. So actually, we defined like 10 or 12 such functions and got the combinations of those and picked the best one. So in here, I have only chosen around 3 for the example. And you'll get some weights for each function like this. And then what we do is like we take the product of these defects against these weights, their corresponding weights. So we would multiply these two together and these two and like that. And then we would get the confidence from this equation. So what we would get is something like this. So you can see I have multiplied these together as I mentioned, and you'll get the confidence value like this. So you can think about that later, how we got the confidence. So it's just a probability, something like that. So this is the equation. And we'll get some confidence like that. So that would be the prediction. So what we would say is like, okay, so we have this for this vehicle at this checkpoint, we have a 66.5% of chance of getting a defect at this mileage. So that was our basic idea. So given the vehicle and the mileage, we would give a confidence for each checkpoint that is applicable for that car. So that this could be something like 66.5% of having a brake failure of that Audi A3 at mileage 70,000. So something like that. So that we used the existing data to make this prediction. So that was our basic idea. And also I'll briefly touch up upon the training phase. So as I mentioned, we defined several functions. So we wanted to pick the most suitable functions for each vehicle type for each ID that I mentioned, the third-party ID, and for each checkpoint as well. So we did the analysis for all of those and defined a score, which I will not be talking about. It's a bit complex. So we defined that score, and based on that, we could identify which is the most suitable function and the window size. So we'll get these parameters out of the training phase. So the function to be used, and of course the window size that we consider 10,000 if you remember in that example. And the confidence threshold, it's a new one because this is actually related to this confidence. So we can say like if we define like a threshold, like 50% or something here, then we can say like if that if the confidence that we get exceeds 50%, then it would be a defect. So otherwise, don't consider that as a defect. So we calculated that as well for all the combinations. So we would get something like this. So for each ID, we would have for each checkpoint, what's the best function and the window size and the confidence threshold. This is in the decimals, of course. Yeah, so this was our training phase. So we keep this in a in the DB, and we use this for our prediction. So whenever a car comes in, like we would look at this and make the prediction using the system. So I'll give a brief overview of the system that we have in place. So as I mentioned, we have these inputs and the outputs. The inputs would be the vehicle that we want. Actually, like there's another layer before this. So what that layer does is like when actually we have the registration number in the uh, user's side. So when they enter the registration number, we have another layer called bus data portal. Through that, we would map that registration number into the relevant third-party ID that we want. So that process happens. And to our system, it's only like we are only getting the ID and the mileage of that vehicle. So this bus data API is separate. So this is actually this was actually implemented as an API. Like you can send a request and then get the response. So we are only communicating with that bus data portal, so that security is very tight there. And also you will have if the customers want to access our service, then they'll have to go through the bus data portal and then get like the auth keys and all of those sorted out there, so they'll have access. And we are only communicating with the portal, and then we don't actually communicate with the external partners. So that layer is also there, which is not indicated here. And what we do is like we get the ID that was mapped from the portal, and then we have the mileage of the vehicle. So through the API, what we do is like, of course, we do all the sanity checks and all that. So after that, for a proper request, we would first query the required data, like I've shown you here, like defining the boundaries. We would query these required rows of data. So after that, what we do is like we look at this outcomes table. Like if we have this ID as 100, we will only consider this set. So we'll query these as well, and then do like the calculation that I've shown you earlier for each checkpoint. And if that confidence value is exceeding this threshold defined for each checkpoint, then it's added to the outputs list. So after doing all of those predictions, then we get the outputs list as the response back from our API. So that's the basic flow of the API. And I'll move into like a few lessons that we learned along the way. This is regarding the like commonly regarding big data projects, and also when using Asia as well. So what we found out was like so this libraries called pandas and all that, they are very popular among like graduates, like undergrads and all that. So we were also using those libraries back in those days. But what we found out was like these libraries are not optimized for handling big data. So like the memory management and also the querying process, like when we want to filter data and all that, that would take a very long time. And also since we have insufficient memory, like usually we have 16 or 32 gigs of memory in our PCs, so that's insufficient, and this would crash. Like so that we should not use pandas or something, those libraries straight away without prior memory management or something like that in a big data project. So the operations are really huge. So what we can do is like we can use Hadoop or Spark. Like the Spark is the most easiest one. I think like we used that using Asia Databricks, so you can try that for your analysis as well. And also you have some libraries called Dask, like it's basically utilizing pandas, like similar data frames like pandas, and then computing it optimally to be handled on normal PCs. So that's a good option if you can't actually access those Databricks and all that. And also if you are unable to get those subscriptions, so it would be very cheap, this Dask library. And also we found out that, like as I mentioned in the training phase, we had to try out many different combinations. So C++ actually performed marginally faster than Python, because in Python we have some like when we do the multi-threading, there's a lock called GIL, the global interpreter lock. So so even if those threads seem like they are running parallelly, they run only like one by one, like they have to acquire that GIL before executing. So there's another finding there. And also if you are trying out like offerings like Data Factory like straight away, please don't use it. Like I mean, like we racked up a considerable amount of bill like trying out those in the research phase. And because those operations that we want to perform, like building the pipeline, is actually very simple in Data Factory. But when we do many operations, that cost adds up. Like if it's related to big data, like just don't do it, don't use it. I mean, like it's very costly. And what we also found out was, like if you are using Asia functions, so if it's turned like always on, that DB session management must be properly handled. Like we in the testing phase, we had this issue where we couldn't uh, identify the bug. Like we had like a small session management issue in the code, and like we couldn't find out like what was wrong, and we have not properly closed that session, and it caused the whole app to crash. Like we couldn't even call the API. So that is a lesson, like that DB session handling is it should be handled very carefully when using always on feature. Like if it's just like not using always on, then it's fine, because all of the instances are getting destroyed at some point, and then the session is getting reinstated. So that's there. And also to wrap up, I think we can uh, we can talk about some ongoing developments that we currently pursue. So actually, like we are considering another model to be implemented within the API to reduce the number of zero predictions. So for instance, like for the ones we can't make a prediction, we will try to give that prediction using that secondary model. So it's in the early stages, so I can't actually present to you like any findings or like something like that here. Uh, we'll try to have a session if possible in the future after that implementation. And also we are currently building a pipeline to automatically update the dataset and also the model, like retraining of the model. Currently it's a bit static and it's not updating, so we are pursuing that as well. And also we are expanding actually to different regions. So currently we are operating in Norway. So the plan is to expand to Sweden and the nearby EU region, like the Scandinavian countries, basically. So in those in those regions, we actually don't have the records in the same format as Boost does. So we have to have some mappings, like from their data to ours. So we are also pursuing that option currently with Sweden, actually. So yeah, I mean, like it's been already like 30 minutes, so I hope you guys got the content that we were aiming for. So if you have any questions, I think the research team is all here. So we'll be more than happy to answer any doubts or anything like that you have. So you can post that on the chat, I think. Yeah. So over to you, like.
Yeah. Yeah. Thank you, Netmal. So it's time for Q&A. So if you have anything to ask and any question, please put it in the YouTube chat, right? So you can see that in right side. So you can put anything if you need to ask. Yeah. So we have a question. So Netmal, we have two questions in there. Let me ask. So first one is this API open to public? Like, can anyone use this API? Like he's just
Yeah.
asking about API. Yeah.
Yeah. For that, actually, you can actually access if you like get the proper authentication. So basically, it's not available for public use. So that's the answer. Like that, the reason being like we can't expose like these are like sensitive data and all that, and it should not be exposed. Basically, like we are offering this as a solution for trusted partners. So yeah, I hope that answers your question.
Yeah. Okay, Netmal. The next one is will there be a future session on the testing approach you taken?
Yeah, I believe that we already had that session. So if we have any improvements in the QA process, we can of course have that. I believe like there should be a recording with the 99X channel. Maybe I think Nadisha did a Q&A, like a QA session just before this, like a few weeks back. So you can refer to that.
Okay, Nepal, here is another question from Nadun, and he's asking that is there any unexpected behaviors you faced in the training phase?
Yeah, like in the implementation, like when we were doing that, like we had to, of course, code for like the training process as well from scratch. So when we were using Python, so like when we fully developed that solution using threads and all that, like we were hoping like okay, like this could run like this would run in a couple of milliseconds and all that. So that didn't work actually. Like the reason is like the GIL lock that I mentioned. So that doesn't like do the parallel computing as expected. So that adds up actually, like the uh, minuscule amounts of processing times adds up to like hours in the end, because we have so many combinations here. Like for all the data, like the testing set would be large, like it's in the hundreds of thousands of range of records. So we have to do the same operation for all of those rows, for all of those combinations, for all of those checkpoints. So that was huge. So yeah, that behavior was there. So that's why we switched to actually C++. So that was much faster, like miles faster, like light speed faster. I mean, like if we are referring to that.
Yeah. Okay. So right. Are there any questions, guys? Looks no. So Nepal, I think we don't have any other questions. Yeah. So we can end up the session. So before that, I would like to thank for Netmal. So Netmal, thank you so much for doing this session. And
You're welcome, Vaira.
yeah. So and also I'm thanking for the audience. Thank you guys to join with us today, and it was a really great session, right? So thank you all. And I have a request from the audience. Please subscribe and like our channel. Right. So please subscribe it. And also, I have a reminder about the next session. So the next session will be held on 22nd of June, right? It's about business intelligence through log analysis. Also, it's related to the boost, right? Yeah. So that's it. Thank you, guys. Good night.
Thanks, guys.